January 2019, a total eclipse of the moon. Astronomers train their telescopes on the darkening lunar surface. They capture a bright flash that lasts around a quarter of a second.
It was recorded. There were a lot of live webcasts and things like that going on at the time. And you can see this flash of light.
What the heck was that?
At first, the cause of the flash was a mystery.
It turns out it was actually a meteorite hitting the surface of the moon. And because it was dark, and because we were all looking at it, we could actually see it.
The moon's dark surface gave us a unique view of what happens when an asteroid strikes.
What was so exciting about being able to see this impact on the moon in a dark area is that we could actually look at the light that it produced and then back calculate exactly what the size of the impactor was.
We worked out that the impacting asteroid was just 20 inches wide. The crater it blew out was 45 feet across. How can something so small be so destructive?
The two things that matter the most are how fast it's going and how massive is the thing. The more massive, the bigger the boom. The faster, the bigger the boom.
Speed and weight are two very important factors to assess how much damage an asteroid will do. Just like a boxer, if a tiny person like me were to swing a punch, it would do a lot less damage than a heavyweight champion.
Same thing with asteroids. The bigger they are, the bigger the punch. But the same thing is fast, right? If I hit you really slowly, it's not going to hurt. I have to really wind back and pop. That's what happens with an asteroid.
The damage from an asteroid strike is determined by its kinetic energy. Kinetic energy depends on two things: speed and weight. Of the two, speed matters most.
If you double the mass, you double the kinetic energy. But if you double the velocity, you get 4 times the kinetic energy.
3 times the speed, 9 times the impact energy.
10 times as fast, it has 100 times the energy. So the velocity is what's really critical here.
The lunar asteroid weighed only 100 pounds, but it was traveling at 38,000 miles an hour, carrying a huge kinetic energy, which gouged out the crater. It's the same principle for impacts on Earth. 50,000 years ago, a 150-foot asteroid hit what is now Arizona. The impact blasted out an impressive hole, now called Barringer Crater.
It's about 3/4 of a mile across, over 500 feet deep. You could put the Washington Monument in the bottom of the crater, and the top of the monument wouldn't quite clear the rim. It's a pretty impressive hole in the ground.
In 2016, impact specialist Kathy Plesko visited Barringer Crater to see firsthand what mass and speed do to the surface of the Earth.
This is awe-inspiring to stand on the rim of a crater like this, understanding just how much energy it must have taken to excavate this much rock. An asteroid came in at about 27,000 miles an hour. It comes slamming into the surface and just explodes. Anywhere nearby here would have seen winds of thousands of miles an hour as the shockwave came out.
The immense power of an asteroid impact comes from the kinetic energy being transferred from the space rock into the surface rock.
It's an extremely violent process, and it starts with the moment of contact of the projectile with the surface itself.
It pushes into the crust, and at first it's just almost punching like sticking your thumb into dough. It's only about as wide as the object is. It's going straight down in, but then it's meeting resistance from the surface of the Earth. And so it squishes until it runs out of momentum, but then it's very compressed, and all of that energy is in a very small space. As it releases, it detonates like a bomb, and that's what makes the impact crater.
Simulations of an asteroid strike in the lab reveal the impact in slow motion. As the high-speed pellet hits the surface, the sand compresses downwards, then rebounds.
And as that rebound is occurring, that's when the material is being ejected out of the crater itself. You'll see the surface erupting outwards like the blooming petals of some big rocky flower as all this debris goes spraying out in every direction.
The 150-foot Barringer asteroid turned the rock to powder. 66 million years ago, an asteroid around 200 times larger and moving 1.5 times faster than Barringer hit Earth. This asteroid impact, called KPG, had so much energy, it turned rock to liquid.
This thing was immense. It's really hard to wrap your head around just how big it is. When it hits, the back end of it is so far back that it's where a modern jetliner would fly.
The KPG asteroid hit the ground with a lethal combination of mass and speed. 1 trillion tons, traveling at 45,000 miles an hour.
Some rock is completely vaporized. It just becomes a gas. You have some rock that it's melted. You have some that's thrown out into space.
This material goes up through that and then falls down and settles down over a huge area. That might be dust, it might be pulverized rock, it might be vaporized metal. It's all of this hot material raining down everywhere.
Some of the rock exploded skywards, but rock below the surface was slammed by a shock wave that was completely off the charts. Rock stopped behaving like rock.
We experience rocks as solid objects, but if you hit a rock hard enough, it flows like water.
The KPG asteroid hit so hard, it pulverized the rock, turning it into liquid.
Almost like ripples on a pond moving away from a stone that's been dropped in it.
It's almost like a splash in the solid body of the Earth itself. And like a water droplet splashing in water, you'll see that central peak will kind of splash up and rise to a high altitude and then come back down again. We think a process very similar to that probably happened in the rock itself at the center of the crater, rising up as high as the Himalayas before relaxing back down into their current position again.
The material slumps, and so these ripples are frozen in the rock. And there are other fragments that go away radially, almost like the spiderweb pattern in glass that you get after it's shot with a bullet.
The KPG impact blew out a crater 111 miles wide. It is the third largest confirmed impact structure on Earth. A large and fast asteroid heading our way is always going to be a problem. So, what do we do? Wait for oblivion or fight back?